Okay, so hi everyone, I'm Daniel, I'm Senior Machine Learning Engineer at JetBrains. I'm happy to be here, I'm happy to see you all. Today I will talk about the new feature that was released by JetBrains on April this year, which is local AI code completion. My team worked on this feature, and today I will share with you some interesting insights about the feature's internals, as well as some of the design choices that we had to make while developing this feature. But first of all, what is JetBrains? It works. And it's my first slide. Okay, JetBrains is a software development company. The main products of JetBrains, as someone may know, are IDEs, integrated development environments for software developers. There are many of them, and since April, as I said, the majority of these IDEs are equipped with out-of-the-box local AI code completion experience, and that is the topic of today's talk. I will start by giving a brief introduction on what is AI code completion nowadays. Then I will go with a bird's-eye view of this new feature that we released, trying to explain why this feature is special. Then I will dig into those details and design choices about this feature. And lastly, I will talk a bit about the team. So let's dig into it. AI code completion. Here's an example of GitHub Copilot. You type some code, you get a suggestion in form of this gray text. And if you like it, you just hit tab and have it inserted into your IDE. How do these features usually work? These features use large language models, and by using large language models, they usually need a cloud server with a powerful GPU to operate. And a typical workflow is depicted on the slide here. You type some code, the code is sent to the internet, to this server, their language model generates suggestions for you, they are sent back and displayed in your IDE. This workflow is quite widely adopted, and of course it has its pros and cons. Let's discuss them. Speaking about the pros, you can go with really big models in this setting because you have your dedicated server with a powerful GPU. Also, nice thing that there are no additional computations involved on the user side because everything about model inference is happening on your cloud server. However, there are some downsides of this approach, and let's discuss them as well. First of all, your code is sent to the internet, and it's absolutely clear that it's not something that everyone and every company could tolerate due to the security reasons. Also, the latency will not be super good because sending the data back and forth via internet is not the fastest thing you can imagine. Also, someone has to pay for the cloud. Either users will pay for the cloud or the company will pay for the cloud. And what we've done at JetBrains, we tried to address these limitations by making this AI code completion experience to work on the user's local device. And before going further, let's think a little bit. Is it even theoretically possible to make this AI experience to work on a consumer level hardware? And the answer here depends heavily on the use case, on our expectations. If we expect our code completion to be able to write the entire method body for us given the method signature, then probably we're in trouble. To accomplish tasks like this, we will need really very large and very smart model. And models like this will not be able to run on the consumer level devices with reasonable resource consumption and latency constraints. But please consider this example. I argue that this code completion is pretty useful because it saves a reasonable amount of user typing. But it's not as hard to generate a completion like this. And given it's a simpler task and it's still useful, we can go with a smaller yet smart model to solve this task and to generate completions like this. And these smaller models will be able to work on the consumer level devices with a reasonable latency and resource consumption constraints. And that is exactly what we call local AI code completion by JetBrains, or officially full-line code completion. It is a local AI that uses tiny language model that runs on your laptop. It's available out of the box in the majority of JetBrains IDEs. It saves vast amount of typing for user. It checks the semantic correctness of generated code before showing you the suggestion, which makes this feature unique. And it does not require any additional subscription. As I said, we released the feature on April, and we had a lot of nice feedback on Twitter and Reddit, some other platforms. And according to our internal questionnaire, 80% of early adopters find this feature useful or very useful. And having all these things in mind, let's go on and let's discuss some interesting details about the feature's internals and design choices that we made during the development of this feature. The high-level schema you have seen already, and it did not change too much. The only thing changed is that language model now resides on the user's local machine. But since today we are attending a technical machine learning event, I suggest to dig a little bit deeper. I promise you there are a lot of interesting things to explore. And here's the more realistic view of what's going on. And what I suggest doing right now is going block by block, exploring some interesting details around the blocks, trying to understand how does this thing works end to end and why all the blocks are important. Unfortunately, due to the time constraints, I will not be able to cover everything during this 25 minutes talk. However, I'm more than happy to discuss all the things I do not highlight now during QA session or of course in the course of this conference. And I really tried my best to pick the most interesting things to highlight here from stage for you. So let's go on. What is the very first thing that you should ask yourself when you're going to develop a new feature, a new product? Well, in my opinion, it is the following. How do I track my progress? How do I make sure that users are really enjoying the new functionality? To answer questions like this, people use online evaluation. And let me tell you, how do we do online evaluation for full-line code completion? First of all, let's consider the screenshot. What you can see here is full-line code completion or local AI code completion, this gray text, and standard ID completion, which is this drop-down list. And question is the following. How do we make sure that adding this full-line code completion really improves user experience? To answer this question, we use industry standard, A/B testing. And for A/B testing, we use something called JetBrains Early Access Program. Early Access Program is an opportunity for users to use paid JetBrains products for free, and by doing so, users explicitly agree to be a part of testing environments of the new features. And in this Early Access Program, we have two test groups of users. For the first test group, we enable full-line code completion by default. For the second, we disable it. And by comparing metrics between these task groups, we are able to draw conclusions on whether or not full-line code completion really improves user experience. So what are the metrics that we are measuring in our experiment? There are two important types of signals that we want to capture during our experimentation. First of all, it's a positive signal, signifying that users are enjoying the new functionality. More code is generated. User has to type less to achieve the same result. And the negative signal, signifying that new feature somehow annoys users. And our ultimate goal here is to maximize the positive signal while controlling for the negative signal, not allowing the negative signal to grow above the baseline value, which is the value for the task group without full-line code completion. And it's worth noting here that if you read some blog posts, white papers around AI code completion, you could probably notice that people tend to focus a lot on maximizing this positive signal while kind of neglecting the importance of controlling this negative annoyance signal. And by the way, AI code completion experience could be really, really annoying, and I will show you the examples later. And at JetBrains, we're deeply concerned about controlling this annoyance metric, about not allowing the new feature to stand on your way. So given that, what are the exact metrics that we use to track these types of signals? For the positive signal, we measure the fraction of code generated, which is the ratio of number of characters generated by IDE, either by full-line code completion or by standard code completion, divided by the total number of characters produced by user. And for the negative annoyance signal, we measure explicit cancel rate, which is the probability of explicitly hiding the suggestion by escape, arrows, mouse pointer, whatever. We measure deletion after accepting rate, which is the probability of deleting the entire suggestion after accepting it. And of course, we measure IDE performance degradation. It should not be the case that because of some new feature, the overall IDE performance degrades substantially. So, given the high-level metrics are disclosed, let's go on and let us see what we achieved in our final A/B experiment. We observed that fraction of code generated increased by 30 to 100% depending on programming language, which means that for some programming languages, by full-line code completion, we were able to double the fraction of code generated by IDE. And the negative metrics did not change, which means that the new feature does not annoy users. After obtaining these nice results, we were able to draw conclusions that full-line code completion really improves user experience, and because of that, we decided to turn this on by default for all users. And that was our approach to online evaluation. Now let's go on and let's discuss a very important block that actually allowed us to combat this negative annoyance metric, which is suggestion post-processing. On this slide, you can see several critical reviews on different AI code completion tools. If summarized, people tend to complain that sometimes AI code completion produces syntactically incorrect code. And if you are familiar with LLM field, and I guess you are since this is ML conference, the reason is model hallucinations. How do we deal with model hallucinations in case of full-line code completion? We show the suggestion only after it was checked by IDE correctness checks, which means that user will never see semantically incorrect code in full-line code completion. There will be no wrong API calls, non-existent methods, non-existent variables, etc., etc., etc. However, there are some downsides of this approach, and let's discuss them. First of all, these correctness checks may time out, and if they time out, we have to hide potentially good suggestions. Also, there will be no suggestions while indexing for some languages. For example, in Java project, if your project is not indexed, you will not see full-line code completion because correctness checks are not available at that moment. And actually, we had a heated debate inside of our team on whether or not we should guarantee code correctness in 100% of cases. And after a lot of communication, after a bunch of analytics, we decided that yes, we want to do our best to guarantee code correctness in 100% of cases because we want to prioritize user trust here. And that is our approach for correctness checks. But that's only part of the story about suggestion post-processing. Let's go on and let's consider the next part. Okay, consider please this example. This return result suggestion is absolutely correct syntactically, but absolutely useless. Second example is even worse. This sort value suggestion is correct syntactically, is useless, and is inserted in the middle of the line, which makes your already written code, these black sort values in this case, to get shifted towards right, which is really annoying. And by observing these annoying experiences, we decided that we need to employ some smart post-filtering procedure to avoid showing annoying suggestions. Unfortunately, we cannot use language model to do that because language model hasn't seen users' actions. And language model cannot predict whether user will accept the suggestion or not. Language models, as everyone here knows, are trained to predict the next word, and they are good at this task, not at predicting users' attitude towards generated suggestion. However, what we can do instead, we can train another model to predict the probability of accepting the suggestion. And as a feature, for this model, we'll use, of course, language model's output probability. We'll use the length of the context, as well as the length of the suggestion. We'll use user typing speed. We'll use entity under the caret, whether it's method, variable, class, whatever, and a lot more features. And for the data set, we'll use early access program again. Early access program is an opportunity for users to use JetBrains products for free. And by doing so, users explicitly agree that more logs will be collected. Although note that code is never collected to the logs, but we do not need code. We need those anonymized features that I described and anonymized actions, targets like accept the suggestion, hide the suggestion, etc. And by using all this stuff, we can train a model to predict the probability of accepting the suggestion given the context and the generated suggestion. And then we deploy this model and use this model to filter out the suggestions that are unlikely to be accepted. After doing so, we of course conducted A/B experiment, and here are the results. The acceptance rate increased by 20 to 50% as compared to no filter model regime. And the explicit cancel rate, our main negative metric, decreased by 50% as compared to without filter model regime. And as you can see, here we were able to match the level of this negative metric of the no full-line test group. So we were able to combat this negative metric. As you can see from this schema, if we use full-line code completion without filtering, negative metric explicit cancel rate doubles. It means that annoyance increases 2 times, which is unacceptable. And by using filter model, we were able to bring it back. And the price we had to pay for that is the drop of the total number of full-line code completion selections by 20%. And that is our approach to suggestion post-processing. Now let's go on and let's discuss how are the suggestions generated on the consumer level hardware, model inference. First of all, let's note, just to be on the same page, that language models are not executables. Language models are just a bunch of arrays of numbers. And efficient inference of language models is a rapidly developing field. In our feature, we use native low-level open-source inference engine called Llama CPP. And let me dig a little bit into the details here. As I said, model inference is rapidly evolving, and generation time using open-source tools rapidly improves. And I want you to feel the velocity of this improvement. Please consider the histogram. It is a very same benchmark, run on the very same hardware with Llama CPP at spring and fall 2023. And as you can see, in terms of latency, we have 40% improvement, which is caused solely by software optimization. Also, as everyone knows, hardware also optimizes really fast. And this local AI area is something that really develops a lot. Maybe you've heard about new local AI features by Apple, by Microsoft. Today you are listening about local AI feature by JetBrains, and I'm sure we'll witness more and more of that in future. So, Llama CPP provides us the most efficient generation, and it provides us out-of-the-box usage of GPU on Apple Silicon chips, which is also nice. And we're modifying Llama CPP for our feature, and we are contributing our changes back to Llama CPP, and by this we're happy to be a part of this nice progress of open source community on large language models inference. And after inference is discussed, let me discuss language models themselves. In our feature, we do not use any pre-trained models. We train all our models from scratch. We use programming language specific models, which means that every programming language or family of languages have their own dedicated model. We use 100 million parameter Llama model with 1500 token context size, which is roughly 200 lines of code. It is the amount of code that model sees while generating the suggestions. The model occupies 50 to 500 megabytes of memory on your machine, which is achieved by quantization of model parameters down to 4 bits. We train our models on AWS instances with 8 A100 GPUs, and full training for one model costs us roughly $5,000. And while $5,000 is a reasonable amount of money, it's not crazy like for large-scale models, it's not millions of dollars. And because of that, We can run this training again and again and again. We can really iterate extensively on model training to find the best performing training regime to train the best possible model of this scale. And this is our approach to model training, and one of the reasons why do we train our models from scratch instead of using some pre-trained ones. And I'm sorry you're showing me the wrong time, because I have my timer and it's 20 minutes exactly. It's not like 25, so please give me time to finish my talk. The next section I would like to discuss is offline evaluation. Hope you understand for now that there are a lot of moving parts in this AI code completion thing. And we need to test a lot of hypotheses to really come up with the best possible user experience. We are not able, unfortunately, to test all these hypotheses with A/B testing. And because of that, we need some hypothesis pre-selection mechanism, which is exactly offline evaluation. We have two types of offline evaluation. It's evaluation of the language model itself and evaluation of the entire code generation pipeline. The former is a pretty standard machine learning evaluation procedure, which is quite straightforward. I do not want to focus on it a lot. Let me instead talk a little bit about how do we evaluate this entire code generation pipeline with all those syntax checks, filter models, etc., etc. To do so, we use our IDEs in a headless regime. And in IDE, we have some number of test files, and we trigger code completion in random places in a file. By doing so, the entire generation pipeline is executed. And we measure some metrics. Metrics based on the match between suggested code and the ground truth code, and metrics based on latency. And using these metrics, we can do hypothesis pre-selection and proceed further to A/B testing stage only with the best performing ones. And that is about offline evaluation. For now, I have unfortunately to wrap up this detailed section because of the time constraints, and let me now talk a little bit about the thing that made this feature possible. The team. Our team consists of 14 people. 3 of them are ML engineers focusing on language model training. 4, including myself, are full stack engineers focusing on making this entire big pipeline work. 3 Kotlin developers focusing on making things work in IDEA, C++ developer focusing on model inference, half-time QA, project manager, and a team lead. And in my opinion, this team structure of 10 to 20 people, full stack, product-oriented team is the best structure to deliver AI features like this. So, what are the takeaways of today's talk? Local AI is rapidly developing. You've probably heard about local AI features by Apple, by Microsoft. Today, you are listening about local AI feature by JetBrains. We will witness more and more of them in future. Making good AI code completion, hope I convinced you in that, is much more than just deploying a good language model. Although a good language model is absolute prerequisite for good AI code completion. Using local AI models instead of cloud makes your development process more secure. And it is still possible to do a good AI code completion based on local AI models. You can try it out in JetBrains IDEs. And a very last thing I want to show you is ArcSci paper on full-line code completion. Although it's a little bit outdated, as you can see, it contains much more technical details about the full-line code completion internals than I were able to share with you now during this 25 minutes talk. Here, thank you very much for your attention. I'd like to wrap up my session, and I'm happy to take some questions.
Okay, Daniel, we have live, big live, and statistic on the slide. Could you switch back to slide when you show typical user of JetBrains products which use top of M1, M2, and 3 MacBooks, and it looked like you try to turn off this feature on the top level notebooks. But why you ignore your long tail users which support you last 10 years maybe, and you personally make me victim because I need to know this feature, because on the my hardware it took to more CPU usage and to more maybe I turn off it earlier because you look like you have some improvements, but I turn off it on the 2024.1 version. So actually it's good feature, but actually it works only on the top hardware. Works good, but on the long trail of your users, it actually could not work.
Thank you for your question. First of all, it's not true that we are focusing on Mac users. According to our statistic, the minority, I cannot disclose the numbers, but it's really low percentage of users that use these new Macs in our among our users. And in all our experiments, all our metrics are measured on average users. The majority of them use Intel hardware, and according to our experiments, for this average user, this new feature, first of all, works okay in terms of latency. We have median latency of this full-line code completion to show up 300 to 400 milliseconds. And secondly, the overall IDE performance does not degrade. Of course, you're right that there is a long tail of minority of users that use some old laptops that probably will suffer from that and will have to turn off this feature. But for average user, for the majority of users of JetBrains, it works okay.
Can you please go back to the evaluation slide?
Yeah, of course.
I was there were two parameters.
Try.
It's
Here?
But that was no evaluation by you. Like, okay, how many people canceled, how many people accepted? Evaluation, success rate. No, the very beginning, metrics. Oh, it's good, it's working.
The metric slide. Okay, let me scroll it back.
So I was wondering, there was no quality as a part of that evaluation.
What do you mean by quality?
Maybe if the developer didn't have the suggestion, he would write better code. But when you have suggestion, you feel lazy, you just accept it and go on.
Okay, got this.
If you look at it, it makes total sense, go on. But if I think about it, maybe I'll write better thing. I saw this actually in practice where there was a list, but we could do settle people, but that's different slide. So I feel just one of those should be quality of the code, not just how many people canceled out, how many people accepted.
I got you. It's a brilliant question, and the entire community working on AI code completion is thinking on this question, and unfortunately, no one has an answer. Moreover, there is a research that says that after this Copilot and ChatGPT stuff, the overall kind of quality of code on GitHub really degraded. And it's a big problem, and no one really knows how to solve it. And unfortunately, I also do not know. If you have the ideas, we can discuss, and it would be really a breakthrough in the industry. I'm not kidding. I will be happy to discuss it in the couloirs.
The only solution I know for now is that code reviewer has to do more work.
That's right.
Thank you very much for the talk. I might extend your question if you don't mind. So, in an inference time when we have the model to do code completion, does it have access to the whole project? So, if it has, how you handle context window limitation, do you use some kind of rugs? And one more question, do you address coding writing style? Maybe developer have this writing procedure, so the completion will be nice if it follows the rules.
So the first question about RAG is an interesting one. Again, everyone is doing that. In our feature, it's currently experimental. It's working for some languages, for other languages are not. We're experimenting extensively to make sure that it really improves the experience. Because the question is that latency will get higher due to the RAG on average, and we have to have a really big improvement to make sure that it improves overall quality. The second question, was
about the writing style. So, for example, if in one project there is some certain rules that develop.
about code style. About the code style, the only thing we can do right now is we can hope that the model, using the context it has, will determine what code style is there. So we do not have some like predefined rules that, for example, in Python, if you use double quotes or single quotes, somehow to detect and to replace everything. But in practice, if you use single quotes in the file, the suggestions will be with single quotes. If you use double quotes, they will be with the double quotes. Of course, it doesn't work in 100% of cases, but like in majority of cases, it works okay.
Thank you.
Daniel, I want to send thanks for JetBrains project I've been using for the last 10 years, and OpenAI is a great help, especially for the languages that I'm not using them often, like Python, right? So I don't give everything in mind. I have two questions. The first one, are you sure that your A/B testing is a fair one? Because you're giving the unstable product to people who are more keen to use unstable features. Like, can you derive the conclusion on testing on that?
Do you mean that this JetBrains Early Access program is a bad estimate of the overall user?
I would say it's not fair. I'm not saying it's bad, because people are more keen to use unstable products.
That's absolutely true. Unfortunately, is a limitation of the policy, because we are not able to A/B test on real paying users, and because of that, it's the best we can do.
Okay. And the second question is like the correctness checker, right? Like for the languages like C++, it's quite complicated thing to do, right? Do you run mean compiler, or like you're just trying to build a and say, okay, it looks like something reasonable, like that, go with that?
There are teams at JetBrains that are really focusing 100% of time on making these correctness checks, and you can see them like highlighting some errors in the code, etc., etc. And we just reuse their work in our feature. Of course, we do not use all inspections that are there in IDE, but we do a lot of work for every particular language to make sure to pick the most appropriate set of these inspections to really make sure it doesn't take a lot of time and it covers a reasonable amount of problems.
Thank you.
Thank you for the talk. Probably like this bunch of very small questions. What's your policy about the latency? How you ended up like using 100 million parameters model, and do you use a personalized approach to the clients, meaning that like people with a better hardware getting let's say not 100 million parameter model, but let's say 200 or like 1 million and so on and so forth?
It's a nice question. Currently, there is no personalization. Everyone is getting the same 100 million parameters, but we're working on this personalized stuff, as you mentioned. How did we end with these 100 million parameters? Experimentation. So we run experiments with the different model sizes, both offline and online. Offline, of course, using like different hardware. And we ended up with that 100 million and 1500 token size. It's kind of an optimal choice for today in terms of trade-off between quality and the latency, and of course the resource consumption on the user side. So that was our approach.
Yeah, and the initial question was like, was policy how much should be the latency that's acceptable for you?
Got this. It's also a nice question. We had an experiment with a kind of slips in code to get the optimal latency. And in our experiments, like roughly optimal median latency is 200 to 400 milliseconds. If it's less, then even in like subjective feeling, you feel that this AI completion is pretty intrusive. It appears too often. And if it's more, then it appears not as often as it should, and the metrics drop. So like this.
Let's thank Daniel again and continue the discussion.